Hello and welcome to our Week 6 class. I hope you're doing well today. So last week we talked about SQL in general without tying it to Python. And in this class, we will be talking about just that. So we will be using SQL in Python code. And one of the popular libraries to incorporate SQL queries into Python is the SQLite library, which when imported into our code will allow us to run SQL queries to create databases, set up tables, as well as add, read, delete, and update data in our tables. Now I will first show you many examples, then I'll go over this week's assignment, which uses the same skill set. Then the second half of this week is an introduction to the Pandas and Matplotlib libraries. Pandas is a great library to work with data, and Matplotlib is a great library to visualize the data. In other words, Matplotlib helps us to create charts and graphs of our raw data. So let's get started first with SQLite, and then I'll move to Pandas and Matplotlib. Now I will skip the PowerPoint presentation portion for SQLite and dive right into the examples. Okay, so in my first example here, I first by importing the proper library, and in this case it's called SQLite 3. Now, SQLite is a popular library due to several key features. The SQLite 3 library is a built-in Python module that provides an interface for interacting with SQLite databases. And these databases are lightweight, disk-based databases that don't require a separate server process. So this results in zero configuration, as no setup or administration is needed, which makes it easy to deploy. And its lightweight nature ensures a small footprint and minimal resource usage, which, as you can imagine, this makes it ideal for embedded systems and applications with limited resources. It is also cross-platform, so it works on various operating systems, including Windows, Mac OS, Linux, iOS, and even Android. Now, this is a built-in SQL library that's part of the Python standard library, so there is no need to install it using pip install command or anything. It's right there for us once we download and install Python. So the import statement again is just import followed by the name of the library, which is SQLite 3. Now, the first thing we have to do anytime with databases, not just with SQLite, but databases in general, is you have to connect to a database. So you either have to have the database already created, or you have to create it and then connect to it. And so the first step we can do with SQLite 3 is to basically call the connect method and then pass it the name of the database that we want to connect to. Now, if this database file does not exist, it will first create a database file for us, then it will connect to it. And just so you know, the .db extension, this is a generic database extension, but for SQLite it could also be .db3, or it could be .SQLite, or it could be .SQLite 3 as well. Okay, so just in case you see it, don't think that it's wrong, but there are different ways you can have file extensions for an SQLite database. Now what this connect method is going to do, again, since I do not have a music.db file already created, it's going to create this file for me, and then it's going to connect to it, and then that's going to basically create a connection object, and I'm going to save, or I'm going to assign this connection object to a new variable called con. Now, to make sure where this database is, it's basically going to get created in the same file where I have this Python code file. Alright, so if I go to where my file is, this is where the file is located right now in this folder. And there is no music.db file. Okay, so now that I have a connection, I need to call a cursor method on the connection object. Now in the database realm, a cursor basically is an object that allows us to retrieve data and manipulate data. So we do need it to start creating some select statements, update statements, and so on. So with the cursor method, as part of the connection object that I just created up here, this is going to create a cursor object. So this is a connection object, but then this method here is going to create a cursor object so I can start writing some SQL commands. And this cursor method is going to create for us a cursor object. Okay, so right now I have two objects, a connection object and a cursor object. Now once I have a cursor object created, then I can call the execute method, which is part of the cursor object. And the execute method basically is going to take one argument, which is the SQL command. Now we've learned about the SQL commands from the last class, so we could write create table commands, we can do select statements, we can do insert into table commands, and so on. So basically this simple file here All I did is I just imported the SQLite library. I connected to a database that does not exist, so it will create it for me and then connect to it. Then I'm going to take this connection, I'm going to create a cursor object from it and call it cur. And once I have the cur object, I'm going to call the execute method and then pass it as a string, whatever SQL command I want to call. And as you can see here, this SQL command basically just creates a new table called tracks, and it gives it two columns. A title column that's basically a string using the text attribute, and another column called plays, which is a integer column. So this is going to be strings, this is going to be numbers. All right, so the table is going to be called tracks. It's going to be in a database called music.db. So let's run this and see what happens. Okay, so nothing shows up or nothing gets returned, but if I go back to my Finder, here is my music.db. Okay, now if I double click on it, again it's registered with the .db is registered with my DB browser for SQLite, and here you can see that the name of my database, music.db, and then in the database structure I have one table and it's called tracks, so far so good. And if I expand it, I get the title column, which is a text-based data type, and then plays is an integer data type. Now if I look in browse data, okay, I do see the table tracks, but it has no data in it yet because we haven't created it yet. Okay, so I'm going to exit out of this, go back to my code, and I'm going to open up another one to go to the next step. So now that we've created our database and we've created our table, now we need to start populating that table. So in the next file, I basically have, well, you're now familiar with these three statements. I'm going to import the correct library. I'm going to connect to my database, which is music.db, which is going to create a connection object. Then I'm going to create a cursor object from my connection object, call it cur. And then I don't need to create my table anymore because the table already has been created. Okay, if you do try to run the create table on the same table name, it's going to give you an error. So that's why I have it commented out. Now there are multiple ways you can add data to a table, and the easiest way, or the common way, is basically using the insert into track statement followed by the name of your columns, followed by the word values, and then followed by the values that you want to add into these columns. So in my tracks table, since that's the name of my table, I say insert into tracks, and then my two columns are title and plays, and the values that I want to add into titles and plays for this specific statement is going to be Thunderstruck and 20. So basically that's the name of the song, and then that's how many times it got played. All right, now you could repeat this statement 10 times or as many times as you like, but that's repetitive, and again it's a lot of work, could take a performance hit, but you can still do it this way if you like. However, I have it commented out. The better way is to basically create one insert statement. I created a variable called insert_command, and in it I created a string literal using the triple single quotes, and inside of it I created the same insert into tracks and then title, comma, plays, and then values. But for the values, I basically lumped up all the different values into one single statement. And the way you can do that is you give the values and separate them by commas. So this is the first value, comma, second set of values, comma, third set of values, comma, and so on and so on and so on, until at the very end you don't need a comma anymore because that's the end of your statement. Okay, so instead of doing it 10 single insert statements, I basically created one single insert statement and wrote it in this way. Okay, so that's what I was saying, is you can create SQL statements using different methods or different approaches, and you always want to go for the one that is more streamlined and the one that is more efficient. So now that I have an insert command, I have to use it in some sort of an execute command. So the execute command, or the execute method, is part of the cursor object, as we've learned before. And now instead of hard coding the actual SQL statement, I'm basically going to pass as an argument the insert_command, which is basically all of this SQL statement. Okay. Now the new thing here is the commit method. Now this is not specific to SQLite 3, but in general with databases, everything is transactional, where when you run a command that basically updates or creates or deletes, in general a command that changes something in a database, the change doesn't happen immediately. The change initially or on a temporary basis is saved into memory. And the only way it gets saved into the database is if you commit these changes. So an insert statement is a statement that's going to change something about my database. So when I call the execute method and pass it the insert command, this is a change to the database. Now the change has not happened to the database yet. Once I run this command, it only happened in memory. Now it will be saved into the database once I call the commit method. Okay, so with, again, transactional databases, you make a change, but you have to commit the change so that it gets saved not into memory, but into the actual database. Then the next thing, after I've inserted this data, I want to test my data. And we'll learn that the select star from the table name, in this case tracks, will basically fetch all the data, all the rows, all the columns from the tracks table. And the way I do that is, again, I call the execute method for my cursor object. So now that I have some data returned, how do I display it? Well, I can loop through it using just a simple for loop. So I'm going to do a for row in cur. Cur is my cursor. So cursor object holds all the data that got returned from my select statement, and now I'm going to loop through them row by row. Okay, and then at the bottom here, best database practices tell us is that when you create and connect to a cursor and create and connect to a connection object, you always, once you're done with it, you need to properly close them. Now, if you don't close them, there's a cleanup job in Python that will close it for you eventually. But why leave things to chances? So we explicitly give the close method on our cursor object, so we can close our cursor, and then we also call the close method on the connection object. Okay, so these two commands you should always call at the end of your database code, just to make sure that you have closed your cursor and you have properly closed your connection as well. All right, so basically this code, what it's going to do is it's going to connect to my music database. It's going to create a connection. When it does that, then it's going to create a cursor from the connection object. Then it's going to start populating data into our tracks table, which we've already created a moment ago or a few minutes ago. Then I'm going to execute the insert command, which is all this. And then I'm going to commit the changes to make sure that it's in the database and it's saved. And then to verify that my data is in my database using Python code, and instead of me looking into the database tool, I'm going to call the execute method and pass it a simple select statement. And then I'm going to loop through all the rows that came back. And once I'm done, I close up my cursor, close up my connection. So let's run this code and see what we get back. All right, so this is basically the select star from tracks table. That's the result. And we can see that all the records have been inserted properly. If you want to double check, we can also go to the file level. Here's my music database again. I'm going to double click to open it. And if I click on browse data, now I see that the title and place columns have been populated with the proper data. All right, let me close this and move on to the next set of code. All right, so now that we've created our database and table and we've populated the table, now we want to run some SQL command to see how we can interact SQL with Python code. So at the very top, you're now familiar with these three lines: importing the correct library, and then create a connection object to the music database, and then create a cursor so we can start running some queries. All right, here you have some code that is commented out. Now, I wanted to demonstrate to you how you can get a count on your database through Python. And the first two methods you could review on your own, and I think you could understand what they mean, but these are not the best ways to get the count of something. But the last method I have down here basically is I have an execute command and I pass it the select count star from tracks. Now we've learned about this method or this approach in the last class. The count method, when you pass it star, is going to return basically all the rows or all the records in that tracks table. Now once we run this SQL command, we're going to have the results in the cursor object. Now in the cursor object there are some methods that we can call. One of them is fetch one, there is also fetch all, there is also fetch many. Okay, but the fetch one basically is all you need if you're trying to get back one row. And we know that select count star from tracks is going to just return one row with one column in it. So the fetch one is good enough to tell us what the value is of this returned, or of the result of this returned select statement. Whatever value comes back, I'm going to assign it to a results variable, and then I'm just going to print it out. Okay, so if I run this now, I get 10. Okay, now 10, comma, that's basically a tuple, and we're interested just in the very first one. So if you want, you see here that I have commented out this line of code. Let me bring it back in, and let's move this out. If I run this, there we go. So the cursor object with fetch1 returns a tuple, and I'm interested in just in the very first one, which is index 0. So instead of printing results to give the whole tuple, I'm basically fetching the first item in my tuple, which is results, and then index location 0. Okay, so that's what fetch1 does. There's also fetch all if you're getting multiple rows, and there's also fetch many if you want to get a certain number of rows. So let's move on to the next example. Okay, now this code file basically is going to demonstrate how we can update data in our tracks table. The first 3 lines you are familiar with by now. Here we have an execute statement that's part of the cursor object, and the statement basically says to update the tracks table and set the place column equals to 33 only where the title is equal to Alabama. So if you go to our music database and browse our data, Alabama is here, and right now the plays count is 223. So I'm going to update the plays value to 333 instead of 223, only where the title is Alabama. And since this is a change to the database, it's not a select statement, I have to commit those changes to my database. And once I make that change, I want to verify it within my Python code. So I call a select statement as part of the execute method, which is part of the cursor object. And then I loop through that cursor object line by line to see what I get back. Okay, so let's run this. And now I get all the records in my tracks table after I've done the update statement. And I can see that Alabama now has 333 instead of 223. So it looks like my statement ran correctly. And also to verify that it is in my database as well, let's open it up again. Let's go to browse data, and here's Alabama, and now it's 333. Alright, next line of code. So again, the first 3 lines we know by now. We have an execute method, part of the cursor object, and now we are passing this SQL code, which is delete from tracks. So delete from tracks basically is going to delete every single record from the tracks table. So you have to make sure that you are 100% certain that's what you want to do. And since delete is a SQL statement that's going to change your database, you have to commit the change once you call that execute method. And then we're going to double check to see what else or what is left in our tracks table, which should be nothing. So we're going to loop through it and see what we get back, which is technically nothing as well. So let's run this. And I get nothing, which is correct. And if we double check in our music database and go to browse data, now the data has been deleted, which is correct. Alright, and the last code example here is dropping our table. So again, same 3 lines. The execute, I'm going to pass this hard-coded SQL which says drop table tracks. So once you deleted data, if you also want to delete the entire table, then you call the drop table command and pass it the name of your table, which is tracks. And again, since that's a change to a database, I have to commit it. And since I'm going to be done working with the music database, I want to close my cursor. I also want to close my connection object. So let's run this. Okay, there is no output. But if we check our music database, I now don't see any tables in my database. Tables 0. Okay, now the assignment for this week, or one of the 2 assignments for this week, involves working with SQLite and Python. And again, please read the context area. For the steps, you can see here, actually let me enlarge it. Alright, so we have to create a Python script, call it library.py. Inside that library, we have to import the SQLite 3 module, and we're going to connect to a database called library.db. And then in the library.db, we want to have a table that is called books. Okay, and this books table needs to have the following columns: an ID column, a title, author, publication year, and genre. And for the ID, again, it's a unique identifier, and so basically it's a primary key. Cannot be repeated, can be duplicated. So once we create our database, once we create our table with these columns in it, then we have to populate it with some data. So we're going to insert data into the books table. And here it tells us that this data can be real or made up, but it should include at least 10 different books from at least 5 different genres. Okay, and you could really make up what the genre is if you want. The point of this exercise is to basically practice using SQL code within Python. So once we have the data in the books table, then we need to start writing some select statements and update statements and delete statements. And here they have them specified for us. So we have to select all books in your table. So that's basically a select star from table. And then we do select all books of a specific genre, again of your choice. So select star from table where genre equals something. And then we have to update the publication year of a specific book. I'll show you how to do that as well. And then we have to delete a specific book from the table. So just a specific record and not the entire records. Or we don't even have to drop the table like we saw a moment ago. So once you verify that you've done all these changes, save your file as library.py and then submit that .py file. Okay, so let's take a look at my version of how this could be done. This code file, again, we start by importing the SQLite library, and then we're going to call the connect method of SQLite and then pass it the argument, which is the name of the database. Now this database doesn't exist yet, and let's verify. Okay, there is no file that starts by library.db. Okay, and then we also have to create a cursor object, and this time I'm going to call it cursor. And then I'm going to create the table. Now, something different I have here in the create table statement is I have this if not exists books, or technically just if not exists. So I mentioned in my previous example is if you call the create table more than once on the same table name, it's going to tell you that this table name already exists and it's going to throw an error at you. But if you have this if not exists phrase in your create table just before the name of the table, then it's only going to run it if the books table does not exist. So it's kind of like a save statement, so you don't double run this command and have a table already existing in your database and then it will create an error and yell at you. So I have a create table if not exists books, and then in my parentheses I'm passing the names of my columns along with their data types. So ID is an integer, and I pass the primary key attribute because it is a primary key column. And then title is going to be string, which is text. Author is going to be string, which is text. Publication year is a number, so it's going to be integer. And then genre is basically also string, so it's going to be text. Okay, now once I've created my table, it's just a skeleton, it's empty, it doesn't have any data in it. So next step is to populate my data into my books table. Now here I'm also doing it in a different way. I'm basically creating a list, as you can see here because of the square brackets. I created a list called books_data, and in it I have a list of tuples that holds all my data in it. The first value is my ID, the second column is the title, and then the author, and then the year, and then the genre. So I have a list of tuples that has 5 items, and these 5 items will populate the data in the different 5 columns. And then I'm going to call a new method that we haven't seen yet, which is called execute many. Now we've been using just execute, cursor.execute, we're familiar with that. And now we're going to use another method called cursor.execute many. Okay, now the difference here is that I'm not calling the command 10 times, I'm calling the command once, but when it comes to the value part, here we go, this part here, I am using question marks. So the question marks basically are fillers. It's basically a value that will be populated different times every time I run this command. And the values will be populated using this variable here. Okay, so starting from the beginning, which you're familiar with, insert into a table name, so you know that part. And then I'm going to follow by all the column names, which these are the 5 column names. Then I'm following by the word values, and typically we've been seeing hard-coded values in here. This time I'm not going to hard-code the values. I hard-coded them into a list variable, and so I'm going to replace them with fillers using the question mark sign. Okay, and then I have a comma, which basically going to tell me where is this data going to be filled in from, which is books underscore data. So that's another way you can write, or you can insert multiple data values into your table using just one insert statement. All right, and then the rest of the code here mostly is commented out because I want to run this first, but I do have the commit line or the commit method to call, because once you make a change, and insert is a change to the database, then you commit that change, and I think there's nothing else in this file. That's okay, everything else is commented out. All right, so let's review quickly. We are going to create a new database called library. We are going to create a new table called books if it doesn't exist, and right now it doesn't exist because there is no library database in the first place. And then I'm going to run an insert statement to populate all this data into my books table. Okay, so let's run this and see what happens. Okay, I don't get any output because there's nothing to display right now, but if I go to my files here, I do now see a library database. So let's double click on it, and I do see one table. It's called books, and if I expand it, I do see the 5 columns, and ID is a, let's see, can I expand this? No, I can't. So ID is a primary key, because you can see there's a yellow key here, but it's too small to see. And then if we go to browse data, I do see the books table, and all the data has been populated correctly. So far we are on the right track. And then the assignment says to, once we've inserted the data, we need to run some queries on it. Here I also have that, instead of running one line, I could have run 10 different insert statements, but again, this is not the most efficient way, but it's a way, but not the most efficient. So the assignment says to do a select statement to find or to return all the data in our books table. So here I'm going to uncomment this guy out. Now I'm going to comment this out as well because I don't need to insert anymore, but I can technically leave this command because I can run it many times and it won't yell at me because I have this if not exists. So this is only going to run if the books table doesn't exist, but since it does exist, then it's not going to run anymore, and we'll see that it's not going to yell at me when I run the following command here. So my next SQL statement is basically select star from books, and here now I have a fetch all. Okay, so we saw the fetch one before, and now I'm using the fetch all. So I want to get all the data back because I'm getting multiple records or multiple rows from the select statement. So I'm going to call the fetch all in my cursor object, and I'm going to assign whatever comes back into a variable called all books. And then I'm just going to have a print statement that says all books in the books table followed by a colon, and then I'm going to loop through book by book in my all books variable and then print them out one by one. Alright, so let's see if that works. There we go, all books in the books table, and here they are displayed for me one by one. So far so good as well. Alright, so let's comment this one out. Oops, not this. Let's comment this select statement out. And then the next select statement in the assignment says we need to select a certain book with a certain genre. Okay, so this is the code that I have. Alright, I created a variable called selected underscore genre, so I set equal to fiction because fiction is one of my genres. And then I'm going to execute a select statement that says select star from books only where my genre is equal to question mark. So now we know that question mark is a space filler or a holder that I could replace with some sort of a variable. So my variable is selected genre, and selected genre is equal to fiction. Okay, and then that's going to be stored in the cursor object, and then from the cursor object I'm going to call the fetch all method because I might get one or more, and then that's going to be stored or assigned to a new variable called genre books. And then I'm going to print out just a statement that says all selected genre, which is in this case fiction, and then I'm going to loop through my genre books and print them one book at a time. So if I run this now, I get 2 books, and these are the records for them. So it looks like it ran correctly. And then we have to run a update command Now notice so far I haven't been using the commit method because select statements are not changing anything, they're just fetching data. But now that I'm going to be doing an update command, I need to call the commit method. So I want to update a publication year of a specific book. Okay, so I'm going to call the SQL statement that says update books, that's the table name, set publication year, which is a column name, set it equal to something, where title is equal to something. So what is this first something here? Well, I'm setting it equal to a variable called new publication year, and the title I'm setting it equal to book to update. And these two variables are defined here. Publication year I'm setting equal to 20, and the book to update I'm using the Great Gatsby. Alright, so basically if we look at the database again, just to verify our data before and after, let's go to browse data. So the Great Gatsby was published in 1925. See, publication year 1925 for the Great Gatsby. I want to change this, I want to update this value to 2020. Okay, so update the books table, set the publication year equals to new publication year, which is 2020, where the title is equal to book to update, which is set to the Great Gatsby. So I'm going to update the publication year of the Great Gatsby from 1925 to 2020. And then I'm going to commit the change to make sure that it's in my database. So let's run this. Okay, there is no output, but to verify, I can go back to my library database and browse data. And now the Great Gatsby is publication year 2020. So that worked. Let's go back to our code again, and the last set of instructions we need to do for the assignment is to delete something from our books table. And we're not going to delete the entire table, we're not going to drop the table, we just want to delete one record, or a record, or a set of records that meet the criteria. So I created a variable called book to delete, the catcher in the rye, and then I'm going to execute the SQL command of delete from books, where title equals to something, and that something is book to delete, and the book to delete again is catcher in the rye. So I do have a book in my library database in my table, in my books table, called catcher in the rye, and here it is. Okay, so this should be deleted once I run this command here. Alright, and once you do that, you have to save your changes, and you do that by calling the commit method, which is part of the connection object. So let's run this command. Okay, no output, but to verify it, let's go back to our library database, browse our data, and we no longer have catcher in the rye. So that worked. Okay, and that wraps up the first assignment for this week, and let's move on to the second half, which will be about Matplotlib and Pandas library. Okay, so I mentioned moments ago that I wanted to talk about Pandas as well, so let's get started on that part of today's class. Alright, so first things first, what is Pandas? Well, Pandas is a Python library used for working with data sets. It's really an amazing library that makes working with data so much easier and faster. For example, Pandas has functions for analyzing, cleaning, exploring, and manipulating data. So instead of reinventing the wheel with complex Python code to work with data, Pandas made this for us in one library to leverage and take advantage of in our code. And a very common question that is always asked is, why is it called Pandas? Well, when I did some research, I found that the name Pandas has a reference to both panel data and Python data analysis. So I guess we can see how these words can be morphed into a catchier name like Pandas. And I also believe that we owe a huge debt of gratitude to a software developer by the name of Wes McKinney, who back in 2008 created and introduced Pandas to the world. It really makes a huge difference when working with data to have this Pandas library available to us. Alright, so we use Pandas because it allows us to analyze big data and make conclusions. Pandas can simply clean and organize messy data sets and make them readable and relevant, which is a huge benefit. So we go from raw data to information that we can use in our decision-making process. For example, Pandas can help us to find correlation between two or more columns of data. And we can also quickly find statistical information like the average values, standard deviation, or the min and max of different data sets. Now, there are some new terminologies that we need to learn about when working with Pandas. I picked the three most common terms, which are series, labels, and data frames. So a Pandas series is like a column in a table. It is a one-dimensional list that holds data of any type, like strings or integers. Then we have labels, which are basically identifiers for the values of our data. It's usually the first column in our table, like the ID or the GUID in a typical table in a typical database. And if no labels are used, then it's defaulted to just index numbers, where the first row is index 0, then the second row is index 1, and so on. And the last term I wanted to share with you is data frame. A Pandas data frame is a two-dimensional data structure, like a two-dimensional list, for example, but in simplest terms, we can say that it's better described as just a table with rows and columns, as you can see from the image here. And the beauty and simplicity of data frames is that we can load files of data right into it, like from a CSV file, and we can also dump data from the data frame to a SQL database or just to a CSV file. So again, very powerful stuff with very little lines of code. Alright, let's get down to some examples. Here in front of us, I actually went to Google Colab, which is a Jupyter Notebook environment online, and I have a lot of examples here, as you can see, and each cell has an example to run. Now, you don't have to use Google Colab for this assignment or for this week at all, but I just used it because I have a lot of examples that I want to run, and instead of having multiple files, I just have different cells, and each cell has an example of code. Now, to use Pandas in our Python code, we first have to import it, but before importing it, for it to work, we have to install it. So I'm going to go to a terminal window, and the install command is pip install followed by the name of the library, which is Pandas. Hit enter. Now, based on this output, you can see that I already have it installed. But if you did not have it installed, it would start downloading first, and then it will start installing it for you. So once you have Pandas downloaded and installed, then we can go back to our code and start importing the Pandas library. Now, I usually like to alias my libraries just because it's shorter typing. So instead of typing Pandas every time I want to use it, I just alias it as PD. Okay. All right. So again, Pandas works with data. So I'm going to create a very simple data series. And again, a data series is just nothing more than a column in a table. Or you can look at it also as a list in Python. So a list is basically just a one-dimensional data set. So now that I have my data defined, I want to use it in a Pandas series. So there is a class in Pandas. So here is my Pandas object. And now there is a series class in Pandas. And the series class takes data. So calling series, I'm going to pass it data. And data is basically this list that I created here. I'm going to assign this to a new variable called column1 or col1, which is going to be a series object. Again, series is just going to be a column of data. And then I'm going to print it out. So let's see what this looks like. Okay, so the output is displayed here. And basically this column here, this is my series. Again, it's a one-dimensional list of data. So what is this column here? Well, this is what we call the index or the label of my Pandas series. And this happens by default. If you don't define a specific label column, then by default, Pandas creates this one for us. So it starts at 0 because it's an index column. So 0 is the label for this value. 1 is the label for this value. 2 is the label for this value. You can think of label again as an identifier. Okay. Now, if you don't want to include in the output a index column, then we can take the series object and we convert it to string and then pass it a property called index and set it equal to false. So basically we don't want to display the index in our column1 series object. So if I print this, I should only get this column back. Let's try that out. And there we go. So now the col1, which is a series object in Pandas, now displays just the data without the index because we set the attribute to false after we call the to_string method, which is a method available to the series object. Okay, now you might want to use an index column, but you want to customize it. Instead of being zeros, 1, 2, 3, 4, and so on, you can customize it. So the way to do this is, again, I'm using the same data. I created a new variable called custom_index, and I'm defining my own custom index. So instead of 0, 1, 2, 3, 4, I'm using A, B, C, D, E. All right, and then again, I'm going to call the series class in my pandas library, and then I'm going to pass it data, just like I did up here. Okay, but instead of just data, I'm also going to pass it another argument called index. Now, I'm not going to set it equal to false, but this time I'm going to set it equal to custom index. And custom index is what I defined up here. Okay, so then I'm going to print it out. So let's run this and see what we get back. All right, so now I get my series column, and for my index, it's been customized using this little syntax. Now just make sure that the number of index values match the number of data, because it's a one-to-one relationship. So for example, if I remove one index and run it again, it's going to yell at me. Okay, and the reason is the length of values 5 does not match the length of index 4, which makes sense. Okay, so again, just make sure that you match the number of index to the number of data items. Okay, now we can also create a series using a data dictionary. Now what this is going to do is, again, with data dictionaries, we have keys and values. Key and value, key and value. So it's going to take my key and make it my index, and then the values is going to be my series column. Okay, so here it goes again. The A10 basically is going to be capital A and 10. The B20 this is going to be capital B and 20, and then the C30 is going to be a capital C30. Okay, so again, I call the series class, pass it the data argument, and then that's going to create a series object for me. Then I'm going to print it out. So when I print it out, there we go. I don't have a index column to worry about anymore because my key has become my index and my values have become my series column. Now, still working with series, there are a lot of methods to take the data that you have in your series object and then dump it to some sort of an outside destination. So here from the name, you can guess to_CSV. It's basically going to take whatever's in my series, okay, which is this, and it's going to dump it to a CSV file called week6-csvdata.csv. Okay, so let's run this and see if that works. Alright, so I don't see an output, well, because the file got created. Now to see a file while working in Google Colab, you basically go to the file icon, and then there it is. And if I double click on it, it's going to be on the right. Scroll to the right. There we go. See, it created the file for us, week 6 CSV data. So the nice thing about Pandas, okay, I can close this now, is that once you have the data in the format that you want it, then you can export it using one of the many to_CSV files. And let's double check, see if we can pull this up. If I do a dot and then to_, there we go. So here are all the options. You can export to HDF, to JSON, to a list, to a NumPy, to a SQL. And so there are a lot of options you could export your data to. Okay, let me just undo that. There we go. All right, next option. Now we're going to leave the series and we're going to go into data frames. So we learned moments ago that series is basically a one-dimensional type of, which is a column in a table, but data frames are columns and rows, which means it's an entire table. Okay, so I'm going to create a data variable and I'm going to set it equal to this data dictionary. It's going to have 3 keys, name, age, and city, and each key is going to have a list of 3 values. So name is going to be Alice, Bob, Charlie, age is going to be 25, 30, 22, and city is going to be New York, San Francisco, and Los Angeles. Okay, and again, just like we had a series class in Pandas, we now have a data frame class that's also part of Pandas. And we can pass it just the data to create the data frame for us. And this is going to create a data frame, and I'm going to assign it a value of df. Series created a series object for us. Data frame is going to create a data frame object for us. I called it df. You can call it anything you want because it's just a variable name. Then I'm going to print it. So let's run this, see what we get back. All right, so this is called a data frame, which basically looks like a table, columns and rows. And my data dictionary keys became my headers, and the values of my keys became my data values. I still have my index column, and if you want to get rid of it, just like we did before with series, which was called call1.toString index equals false, we can also do the same thing down here by calling the toString method, this time of the data frame, and pass it the index argument and set it equal to false. So when we run this, now we get the same exact table, but it's missing the index column. Now you don't always have to print the entire data frame. Okay, so if you want to print just the name column or the age column or whichever column you want, the syntax for it is to call the data frame by its name, which in this case it's df, and then in brackets just pass the name or the names of the column or columns that you want to display. So if I print this, I get just my name column. Now we can also, just like we used to dump data, let's see, where do we do dump data? Just like we dump data up here to a CSV file, we can also go the other way around, which is reading from some sort of a data source. So in this example here, what I'm doing is I am going to call the read_CSV. So basically this means I'm reading from a CSV file. Now this is a method, part of the Pandas library, and basically takes an argument of the file's name. Now this file needs to be found in the same level as the code that you're working with, since I don't have a path. But if it's located somewhere else, then you could basically specify the file path here by giving it the full path to where this file is located. In my case, because I'm using Google Colab, I have it in my files folder, and week 6 data, here's week 6 data. So what I'm going to do is, well, let's open this up first. So this is my file, and that's the data in it. Okay, it has 4 columns: duration, pulse, max pulse, calories, and you can see that it has multiple records, a total of 169 entries. So what I'm going to do is I'm going to call the read_CSV method, which is part of Pandas, and I'm going to pass it the name of the file that I want to read, and it's going to take all this data and then dump it into a new data frame, and I call this data frame df from CSV. And then I'm just going to print my data frame from CSV. You see here that I'm calling the name of the data frame as is without using the print command, which is also possible in Google Colab. So I'm going to run this. And when I scroll down, I get my entire, well, technically it's not the entire data frame, but because you see the top 5, and then you have ... which basically tells you that there's more rows that are hidden just for display purposes, and then it shows us the last 5 rows as well. Okay. Now, if you wanted to get part of this data, then there is another method which is part of the data frame object called head. Now head by default returns the first 5 records of your data frame. So I'm going to call the head method with no arguments passed as of now, and it's part of the data frame that I want to use, which in this case is the data frame from CSV, and I'm going to print it out. So let's run this, and I get just the first 5 records of my data frame. Okay, so head is a method that's part of the data frame object, and it returns the first 5 records. If you want to return just the first 2, then as an argument pass the number 2. And then if you run it, then you get just the first 2. And if you wanted just the first 25, then type 25 and then run it, and then we get the first 25 records. Okay. Opposite of head, there's also tail. Okay, so as you can guess, since head gave us the first 5 records, tail is going to give us the last 5 records. So if I run this, I get the last 5 records here. And again, if you want to get just the last one or last two, then you just pass the number here. So let's say I want to get the last 3 records. And there we go. Okay. Now data frames also come with a slew of other methods. One of them is info. Now info, as you can guess, is short for information. So if you want to take a guess also, information or info method is going to return some information about our data frame. So I'm going to run this and see what kind of data we get back. Alright, so first of all, it tells us the data type, which says it's a data frame type, and it has 169 entries starting from 0 to 168. It has a total of 4 columns, and these 4 columns are here: duration, pulse, max pulse, calories. And we have 169 non-null, meaning that every value in the duration column has some value. There are no blanks. This one has no blanks. This one has no blanks. But this one, calories, has 5 blanks. And then the data type of each column is integer 64, integer, integer, and then float. Okay. It also gives us some memory usage as well as the total of the data types. We have 1 float and 3 integers. Okay, so this is all comes back to us just from the info method. Another method also is a describe method. Now this is going to give us back some statistical data like the min, max, the mean, standard deviation. So let's run it and see what we get back. Alright, so for every column we get the count, we get the mean, we get the standard deviation, the min, the max, and we also get the percentiles, the 25th percentile, the 50th, and 75th. Now, many times when you're working with data frames or tables or data in general, you sometimes get empty cells, and empty cells can throw off or can skew your data when you're doing some data analysis. So there is a method in data frames called drop NA, drop not applicable or not available. So this is a method that will drop empty cells for us. So here I'm creating a new data frame by calling the data frame class of Pandas library, and I'm passing it, or I'm hard coding the data here. And the data here is basically a data dictionary that has 2 key value pairs. The first key is A with a value of a list of numbers, which is 1, 2, and then none is basically the blank value, and then 4. And then my second key is B with values of 5, 4, 7, and 8. So this is valid, this is valid, this is blank, so it's not valid, and should be dropped. So I am creating a new data frame with this type of data, and I'm calling the new data frame df underscore missing. Then on this new data frame missing, I'm going to call the drop NA method, which is going to drop any records or any rows that has missing data. And then this modification is going to update my df missing data frame, and then I'm going to print out my data frame. Or if you want to see it, just so we can, let's print the df. Okay, there we go. So I'm going to print the data frame before, and then I'm going to print it, and then I'm going to do the change. I'm going to drop it. Then I'm going to print the data frame after the change has been made. So let's run this. Okay, so here's the data frame with the missing data, and then here's the data frame without the missing data. Okay, so you can see that row 2, which had the missing data, has now been dropped because we used a drop NA. Okay, so again, a lot of methods in data frames that allow us to do so many things very quickly. Another method worth mentioning is the drop duplicates. So again, many times when you're working with data, you don't want to have duplicated data, so you want to delete them. So drop underscore duplicates does exactly that. Here I'm going to create a new data frame, again from Pandas, and just like before, I have an A key, and the value is 1, 2, 2, 4. And then a B key with 5, 6, 6, 8. So you can guess that 2 and 6, 2 and 6 are duplicates. So I need to delete them. So I'm going to create a new data frame called df duplicates from this new data frame data. Then I'm going to run the drop duplicates method on this df duplicates data frame, and then I'm going to print it out. So let's run this. And there we go. Index number 2 or row number 2 is no longer here because 2, 6 would have been the row for number 2, 2, 6 also, so it got dropped because we called the drop duplicates on this data frame. Now we can also filter data on our data frames, kind of like the SQL statements where you do a select something where something is something, with the where clause. So in data frames we can also do filtering. So here's the syntax for it. I'm going to basically create a new data frame where the data frame age is larger than 25. So again, this is the name of the data frame, df. Now we've used so many data frames. This one is called df duplicates. This one is called df missing. These are different data frames that we've been working with in all these examples. This is called df from CSV, but the df data frame that we used initially is, there we go, this one here. Okay, this is the df data frame, which is using this data. And this data basically is going to show up like this. So we have a name column, age column, and a city column. And for the age values, I have 25, 30, and 22. So in my code down here, I want to filter on the data frame where age, the age column, is only larger than 25. Now this expression is going to create a new data frame for me. I'm going to assign it to a new data frame name called df_filtered. Then I'm going to print it out. So let's run this. Okay, so I get back on the first row, I get a false. On the second row, I get a true. On the third row, I get a false. So we are looking for something that where age is larger than 25. So if you go up here to our data, okay, so here we go. Index 0, is it larger than 25? No, because 25 is equal to 25. So that's a false. And then index row 1, 30, yes, 30 is larger than 25, so we get a true. And then index row 2, 22 is not larger than 25, so we get a false. So that's where this true and false stuff came back with, okay? But that's not very helpful, or it can be helpful in certain situations, but I want to get the actual rows with the data that meet this criteria. Now to do that, I have to change my syntax a bit and say this. So I'm going to say, now df age is just the age column in the df frame, but it's also a part of the entire data frame. Okay, so I have to put the df and then brackets and then df age and then say larger than 25. So basically we're filtering on the entire data frame on the age column where that number is larger than 25. Okay, then I'm going to run this, and now I get the actual data frame with the values and not just true and falses. Okay, so play around with all this and see what comes back for you. Now we can also, just like we do filtering, we could also do sorting. So in data frames, there is a method called sort values. And you need to specify, well, you want to sort by what. And the by what part is you give it a name of a column. So sort values is a method that's part of data frames. And it takes an argument called by, and you set it equal to a column name in single quotes. And that's going to create a new data frame. And I'm going to set it equal to df underscore sorted. And then I'm going to print this newly created data frame. So let's run this. And now I get my data frame back. And notice that the age is sorted from smallest to biggest. So 22, 25, 30. So the data has been shifted or has been sorted by age. Now notice that the data by default has been sorted in incremental order or ascending order. Okay, but I can also call the sort values, give it the by argument, but then add another argument called ascending and set it equal to false because the default is ascending. Now I want to revert it, so I want to set ascending equal to false. So this is going to give me data sorted by the age column in descending order. So let's run this. And that's exactly what I get. My data frame organized or sorted by age in descending order, 30, 25, 22. Now another library that I wanted to discuss today is the Matplotlib library. Now this is used for data visualization. Basically it allows us to take our data and graph it. Now Matplotlib is a third-party library that we have to install first. So if I go to my terminal window, let's expand that, and I'll type the typical pip install followed by the library name, which in this case is Matplotlib, and then hit enter. As you can see here, I already have it installed. But if you did not have it installed, it's going to start downloading, and then it's going to start to install it for you. But once you have it installed, then you can start importing it. And the import command is import matplotlib, which is the big library or the big package. And then inside of it, there's another module called pyplot, which is what we need to create our graphs and our charts. So I'm going to import matplotlib.pyplot, and then I'm going to alias it as just plt. Okay, and since I'm going to be using pandas for my data, I'm also going to run this cell so that I could have both pandas and matplotlib ready so I can use them in my code. Alright, now I'm going to read some data that I want to plot from a CSV file. So this CSV file is again in the files section, and here it is. If you double click on it, let's scroll to the right. Here's the file that I'm going to be working with. So I have an ID column, I have a subject name, instructor name, num grade, and letter grades. So this is just basically a grading book for a sample class. And this is the file that I'm going to be working with. So let me just close that for now. So again, I'm going to call the read CSV method of my pandas, and I'm going to call this file. And all the data in this file is going to be read into a data frame. I'm going to assign this data frame a name of df, then I'm going to print it out. So if I run this, I get the data frame with all the expected data that I just saw moments ago. Alright, so now we have data. Now I want to start plotting it. I want to create different type of charts and plots. The first one is a histogram. So a histogram basically is very similar to a bar chart, but the data is squished together. And the reason for it, or the analysis we get out of it, is different than a bar chart. So what I'm going to do is I'm going to use the data frame, not the entire data frame, but just the num grade column, okay, which is this column here. So I'm going to use just this column of my df data frame, and whatever comes back, I'm going to assign it to a value called x. Then, inside my pyplot library, there is a method called hist, and hist is short for histogram. Histogram expects some arguments, but the minimum is that it needs data, and my data is x, which I just defined up here. And then once you have built your histogram, then you have to call the show method of your pyplot, and that will display the actual chart or plot that you're trying to display. So if I run this, here's my histogram. Now if you look at it, it's a little bit confusing. Okay, I do see some grade values down here. I have some values on the left here. And then I have these what look like different bar charts or different rectangles. It's kind of confusing, right? So as is, histograms need to be customized to be able to give us more data, or to give us more valuable and meaningful data. So this is a plot, a histogram plot, but it doesn't tell me much. So what I'm going to do is, down here, I'm going to customize the histogram method. Now, if you're familiar with histograms and working with them, you would know that each area is called a bin, and the bin holds your data. Now, what I'm going to do is, I'm going to use the same exact data set, okay, the values from the num grade column of my df data frame, but I'm going to create my own bins. So I'm going to create a variable called myBins. I'm going to set it equal to a list of 50, 60, 70, 80, 90, 100. Now why did I do that? Well, because when you study your data, you see here that the num grade column starts with the lowest value of 54 and goes as high as 100. So I'm going to create bins, or you can think of them as areas, where it starts at 50, because there's nothing lower than 50, and go all the way in tens, all the way up to 100, because there's nothing higher than 100 in my num grade column. Then I'm going to call the histogram method again, or the hist method of my pyplot, but this time I'm not only going to give it the x value, which is the data, which you have to give it data, because you have to plot something. I'm going to give it another argument called bins. Bins is another argument you can pass to the histogram method, and you set it equal to some bins that you want to use. Well, I want to use the myBins variable, which has 50, 60, 70, 80, 90, 100. Okay, I could stop here, but I also want to show you more customization where I can call the color argument and give it a color of red. So this is going to appear in red instead of blue. And then the edges of my bins, using the edge color argument is going to be set to black to give it more of a separation of bins, and then those edge lines are going to be 2 pixels wide, so they could a little bit stand out. Now these are just some of the arguments you can use to customize your histogram. Now up here there was no title, there were no axis names, nothing. Okay, so I can call the title method of my pyplot and give it the name of the title. Now this should appear in the top here. I'm going to call it number grades, and then for the X label and the Y label, you call the X label method and then give it the name that you want to use, which is going to appear down here. And then for the Y label, I'm going to call it subjects, which is going to appear on the left side here. So X label and Y label, and title goes up here. And then once you have all that, to actually show the histogram, you have to call the show method of your pyplot library. And then run this. Let's see what we get different now. Okay, so this looks much better. I have a title for my plot, which is number grades. Here I can see these are subjects, and then down here are the grade ranges. So I have one subject that has a grade somewhere between 50 and 60. Okay, now histograms are for distributions. And then I have 2 subjects that have grades between 60 and 70. I have one subject with a grade between 70 and 80, and then I have 3 subjects that are between 80 and 90, and another 3 subjects between 90 and 100. So with these customizations, I was able to get a more meaningful histogram than this not so meaningful histogram. And I did this by adding some more customization to the basic X data, like I did here with my bins, and some title and X label and Y label. Okay, and again, the line width of 2, that's the line here. If you increase it and run it again, you'll see that the line width has increased to 20, which doesn't look very nice. So again, play with it and see what you get back. Alright, so that was histogram. Another thing we can do is we can plot a bar chart. So bar charts need a X label and a Y label, or need an X axis data and a Y axis data. So for the X, I'm going to use the subject name, and for the Y, I'm going to use the num grade. Okay, again, the syntax is you call the data frame name, which is df, and then in brackets, you pass it the name of your column for both the X and the Y value. And then I'm going to call the bar method, which is another method in pyplot that allows you to create bar charts. You have to pass it at least the X and Y variables, which are the X and Y data, and then the rest are optional. Okay, but I kept kind of the same thing. I used color, this time it's pink. I use edge color, this time it's gray, and then I use line width, and I kept it at 2. Then I define my title, and I define my Y label, and then I'm going to show it. So let's run this. Alright, so now I get my, the title subject grades, and then down here I didn't specify a X label because they're going to get the values from the name of the subject. And then down on the left side I have grades. So math, for example, has a score of, well, looks like almost 90. Science has a score of low 80, and so on. So again, if you match it against the grades here, you're going to find that this is just correct. Now history has a line here because history has 2 entries. One with a grade of somewhere in the 50s, and then another one with a grade somewhere in the 70s. And again, if you double check the data, here, let's just do that. History somewhere in the 70s, and history again somewhere in the 50s. Okay, so that part was correct. Alright, we could also do a scatter plot. Now scatter plots are basically where you have data scattered all over the place. And again, we define 2 sets of data, the X and Y variables. Then we call the scatter method, which is a method to create a scatter plot in pyplot. Then you have to pass it at least the X and Y for data, but then I also went ahead and gave it some extra values for the color, edge color, and line width. And then I gave it a title, and I gave it a Y label, and then I'm going to show it. So I'm going to run my cell, and here we go. We have the title, and here's the scatter chart where all the data is scattered, and then the name of my subjects, and then their grades. Okay, so again, same data, just shown as a scatter chart or a scatter plot, as opposed to a bar chart and as opposed to a histogram. And the last plot I wanted to show you is a box plot. Now the box plots, if you're familiar with data analysis, is sometimes referred to as a whiskers plot, okay, because it has, well, I'll show you in a moment. All right, so I'm going to create a new data frame from my numGrade column, and I'm going to assign it a value called ng, and then there's a method also part of pyplot called boxplot, and boxplot needs some sort of data, so I'm going to give it the ng variable that I just defined here, which should contain only the numGrade column, and then I'm going to show it. All right, so let's just display that. 3 lines of code. It's going to give us all what I need. So this is a box plot. Again, it's a box. It's called whiskers because the ends here are basically the whiskers. Okay. Now to understand what this means, this is the minimum value, the whiskers here, and the other whiskers here is the maximum value. And we do know that 100 is the highest score, and 54, which this looks like 54, is the lowest score. Now the box basically holds the majority of the values. So most of the grades are from somewhere in the low 70s to the mid 90s. Okay, and the orange line here, that's the median. Okay, so that's what it's called, a box plot. Now if you want to get more information, you can call the box plot again, give it the data that you have to give it, but you can also, instead of making it vertical as you see here, we can make it horizontal. So I'm going to pass the vert argument, so this time set equal to false, because by default vert is equal to true. And then I'm also going to pass another argument called show means and set equal to true. So means is basically the average. Okay, this is the median and means is the average. I'm going to set equal to true, so it's going to show up somewhere whatever the mean should show up. And then I'm going to define the title. I'm going to define the label, the Y label, and then I'm going to show this newly updated box plot. So if I run this, there we go. Now it's horizontal. I still have my whiskers, I still have my box, and I still have my median, and now I have my mean, which is here. Now we also, this box plot, this one as well as this one, they both show also the percentiles. So this first area before the box is called the 25 percentile, and then here in the box this would cover the 50 percentiles, which is this 25 and then this 25 would add up to 50, and then this last one, that's the last 25 percentile. Okay, so that's what a box plot looks like. Alright, now we can do a lot of statistical analysis and get some information, and as we've seen before, there is a method called info, another method called describe, and I didn't show you this yet, but there is describe, and you can pass it a value or an argument called include, and then you set the value equal to all. And I'll show you why we do that. So let's run the info first, again on my data frame df, and when we do that, again we get the data type, which is a data frame. We have the number of entries of 10 from 0 to 9. The different columns are 5, which are these 5 columns, and then we have no null values, and then the data types and all that. Okay. Now for the describe, look, when I run this, what's going to happen. I only get back 2 columns, the ID column and the numGrade column, but I know I have 3 other columns. What happened to them? Well, describe is basically used for statistical analysis, and statistical analysis usually handles numbers. So if there's a column that has non-numbers, again you can see here that, so as you can see, ID is an integer type, so that's a number format, so it's included, and then numGrade is also an integer type, so that's included. So these 2 columns are integers, so they get included in my statistical data because I can count them, I can get the mean, I can get the standard deviation and all that. Okay, but if you want to force the describe method to do all this analysis on all the columns, meaning that the subject name, the instructor name, the letter grades, all which are non-integer types, then I need to call the describe method again, but this time pass it the include argument and set equal to all. So include all the columns regardless of data type. So when I run this, I get all the columns, but it's pretty much going to include data that's not helpful because you can't get standard deviation of a string value and so on. Okay, so only the ID and the numGrade are the 2 columns that would make sense in this statistical analysis. Now, you don't have to call the describe and the info methods or statistical methods on the entire data frame. You can call it on certain columns only. So here, for example, I'm going to call the describe method, but only on the numGrade column, which is part of the df data frame. So when I run that, I only get data just on the numGrade. So all the count, mean, standard, min, all that, all the statistical information gets called just for the numGrade column. Okay, I could do the same thing also if I just want to get the mean. So instead of getting all this data, say I just want to get the mean. Okay, then I call the mean method on my numGrade column, which is part of my data frame. And when I run it, I get just the mean value. And the same goes with the mode method as well. This is only going to return the mode value of the numGrade of the data frame df. So if I run this, I just get the mode values for the numGrade. And if I want to get the min, I run this and get just the min value. And if I want to get the standard deviation, I run it and I get just that value. Alright, so then these examples gave us some practice for the assignment. So I'm going to go to our assignment. And this is the second assignment for this week. Again, please read the context area. And then for the steps, it says to create a Python script, call it dataanalysis.py. And then we have to import and install the necessary libraries, pandas. NumPy you don't have to use if you want to hard code your data, but you can use also NumPy if you want to create some data arrays. And then Matplotlib, so we can create some plots. And then for the dataset creation, it says create a dataset of your choice. Just make sure that the dataset contains at least 4 columns and 10 items or entries. And it says refer to resource 1 for guidance, which is down here. Okay. Next, we have to do some statistical analysis. So we have to compute the mean, the median, the mode, the standard deviation for some columns in your dataset, and then include comments in your code to explain the purpose of each line. For data visualization, which is basically creating data plots, we have to use Matplotlib. We're going to create a histogram of at least one of your columns, allowing you to visualize the data distribution in your dataset. And also make sure that you comment your code. Once you've tested everything and the output is as expected, please submit that data analysis file. Okay, so my interpretation of this assignment is this. Again, I'm using Google Colab to create a Jupyter notebook. You need to submit a Python file. But again, I'm doing this so I can have different cells to run for you. Okay, so we're going to import the necessary libraries. Notice how here I'm commenting my code. And then I'm going to be using Pandas, so I'm going to import it and then alias it as PD. Now, before I use this import line, which is import matplotlib.pyplot as PLT, this works fine. There's another way also to write it, which is from the matplotlib library, import only the pyplot library and then alias it as PLT. So I just wanted to show you that these two lines do the same exact thing, but worded differently. Then we have to define our data set, and again it said at least 4 columns with 10 items in each. Okay, so I basically created my 4 columns using a data dictionary. The key is going to be my column, so I have name column, age column, salary column, experience column, and then each of these columns is going to have 10 items or 10 entries. So that's my data set defined here. Then I need to create a data frame, which I'm using the data frame class, and I'm passing it the argument data, which is this data up here, and it's part of my pandas. And then this is going to create for me a data frame, which I'm going to assign the variable name df. Again, you don't have to call it df, you can call anything you want. I'll just choose to call it df in this instance. Then it's asking me to do some statistical analysis. So I have to calculate the mean, the median, the mode, standard deviation for some of the selected columns. So I'm going to pick the age column in my df data frame, and I'm going to calculate the mean on it. Because again, remember, you can calculate the mean on a single column instead of an entire data frame. And then whatever value gets returned, I'm going to assign it a new variable called mean underscore age. Then I'm going to calculate the median using the median method on my salary column and give it this variable name. And to calculate the mode, I would use the mode method. Now here I'm passing it the value 0 because the mode method returns the most frequented item in our list. And values of index 0 is going to return the most frequented item. If I do index 1, it's going to return the second most frequented item, and so on. So the 0 index would return the most frequented item in my experience column. Next method I want to use is the STD, which is standard deviation. And I'm going to apply it to the salary column of my DF data frame, then assign a column of std underscore dev underscore salary. Then I'm going to print out all these values that I calculated up here. So I'm going to print my mean age, the median salary, the mode experience, and the standard deviation of salary. Then I'm going to plot a histogram. Now for the histogram part, you are familiar with calling the hist method, and the hist method needs at least one set of data set, which is going to be my age column, and I'm going to be using 10 bins. I'm going to give it a color of sky blue and the edge color of black. Then I'm going to give it a title, an X label, and a Y label, and then I'm going to show it. Now here I'm using another method called figure. Now figure method basically gives me control of how I want the size of my screen to show up as. So actually, let's just comment this line out for now, and I'm going to run this code as is. So basically, from the very beginning, we imported the Pandas library, the Matplotlib, we defined our data, we built our data frame using this data, and then we calculated the mean of different columns like age, the median of salary, the mode of experience, and the standard deviation of salary. And then I printed all these values out, and then I started to plot a histogram of the column age of my data frame with 10 bins and some customization here. So let's run this and see what we get back. Alright, so here are my print statements, the mean, the median, the mode, the standard deviation. And then for the actual histogram, I have my 10 bins. Okay, these are the 10 bins. And then these are the frequency for the Y label. My title is distribution of age as expected. And down here I have my age values. And this is sky blue with a black label. And yep, that's the customization I used. Okay, now if I change the figure size and run this again, you see that the table has expanded to some sort of a different size. Okay, so you can, with the figure method, you can configure your figure size to heights and lengths. Okay, so that's my interpretation of this assignment. Again, if you have any questions, please do let me know. I'm here to help you as much as I can. So I hope you have a good rest of your week, and I'll see you in class. Take care, and bye for now.